Welcome once again. It's a great day for pre-calc. Today we're going to take a look at parametric equations. All right, we begin. Parametric equations. Okay. To this point, we've been dealing heavily with equations in rectangular form. That would be with x's and y's, and we have also taken a look at polar equations, which used r and theta as their variables. All right, parametrics. All right, will be kind of special. It'll be split into both an x and a y component, and you'll also see the use of t in our problems. Okay, first thing we're going to do, we're going to try to convert back and forth. Okay, first one. All right, I give you this parametric equation, and we're going to convert that to rectangular. The name of the game is substitution. All right, you could take either one of these, solve it for t, because that's the letter that's in both pieces, and sub it into the other. So let's take the top one. How do we make this t by itself? We've got to get rid of the square. How do we do that? Square root. So what does t equal? Square root of x. And in it goes. We're going to sub in right there. So we can convert this to say 2 radical x plus 3. Now, no longer is it split into two pieces using parametric notation. Now it is in rectangular form with just x's and y's. Now I want to take a look at the graphs so that you can make some connections here. Okay, you probably know that graph is basically what you have there, the square root graph. You'll also remember your rules of transformation. That 3 being outside of our original parent function will move the graph up 3. Okay, and this multiplier being a big number, bigger than 1, will make it a little bit taller, a little steeper. Okay, so time to get a calculator, be that TI or Desmos. Okay, and you're going to start by going to mode, and you'll see here we're going to change function to parametric, par, on this one. At least for right now, we can leave it in radians. Okay, and now check out what happens when you press y equals. There you'll see the split. So every equation has an x and a y. It's in parametric form. Okay, so what did we have to put in here? T squared for x, 2t plus 3 for y. All right, so square root, or I'm sorry, t squared. All right, where's the t? Remember this button that had x and theta that we've used? All right, also has a t. So if you hit that one now, you'll be getting t's. There's t squared, here's 2t plus 3. Okay, and we hit graph, we get our square root graph rising from 3. There we go. All right, let's try another one, but let's spice it up. All right, the appearance of the trig functions means everything you know about trig, it could be used here. All right. Again, we're going to convert this to rectangular. All right. Now, being rookies, you really don't know what shape that is yet, just by looking at it. But good news, the more you do, the better you get, and you'll start to recognize things, just the way they're given to you. You'll look at it and say, oh, that's a circle, or oh, that's a line, that type of thing. So, substitution is still the name of the game. All right, this top one, let's solve that for cosine. What do we got to do to get that by itself? We'll add 4 and divide by 3. You add, let's do it this way. Let's get cosine by itself. So we'll add 4 and divide by 3. All right, how about for sine? Okay, we're going to subtract 1 and divide by 3. All right, now, the first problem we did, we solved for t and made substitution. If we go that far here, chaos in my world. We don't want that. All right, again, experience told me that we're going to use our trig identity knowledge here. All right, which one on your gold sheet was the most valuable, most useful one you had? It was sine squared plus cosine squared equals 1. And that's the one we're going to use this time. All right, making the substitutions. Okay, sine is this guy. And cosine is this. All right, we have converted it to rectangular. Mission accomplished. All right, but let's try to make some connections. What shape do we think that is? All right, at first glance, you're thinking perhaps an ellipse. All right, and you'd be close. However, let me move this over here. This piece if I square the top and the bottom, I get that. And this. Looks like so. All right, because these numbers are both the same, it's not an ellipse, but a circle, okay? And we could multiply everybody by 9. And what do we end up with? Everybody knows that's a circle with the center at -4,1, and, sorry, that was a 9, and our radius of 3. Okay, so there's some practice converting parametrics to rectangular. Okay, spicy, that one. Okay, next up, we're going to be asked to graph this parametric, and there's really 2 ways to do it. Let me show you which way I think would be the best. All right. Again, at first glance, maybe we don't know what that is just yet. All right, so we could convert this immediately to rectangular. Let's go. Top one, how do we solve that for t? Move the 2 by multiplying by half. Okay, and let's make that substitution. Since t equals half x, we'll go ahead and put that in there. All right, so everybody with their Algebra 1 skills knows that's a what? That's a line with y-intercept of 1 and a slope of up 1 and over 2. Okay, or we could go down 1 and backwards 2. And what we have here is a line. However, all right, what haven't we taken note of yet? They wanted this only graphed from the interval of -2 to 3 with regards to t. Notice the brackets are inclusive. All right, so we won't have any open circles here. Okay, now what's the easiest way to do this? Because remember, on our graph we've got an x and a y in our equation. No t on that graph. So here's my suggestion. We're going to plug in -2 here and here, and that gives us what? -4, comma, -1. And now we're going to do the same thing for 3. Plug in a 3, double 3 is 6, 3 plus 1, 4. So really, we just want to graph this from -1 to 6, 4. Okay. So you will get this piece of that full line that we graphed to start the problem. Okay? So that's graphing over an interval. All right, and our final problem of the day for parametrics, save the best for last, you know that. We're going to cross over into physics a little bit with a look at projectile motion, all right, which makes use of parametric equations. All right, so if you've had this in physics already, you will be ahead of the game today. All right, if you haven't, you'll be ahead of the game in physics when you do projectiles. All right, here's the parametric equation split that represents projectile motion. All right, let's take a look at these and identify what are these variables. Okay, V sub O means initial velocity. You know, theta is our angle, T is our time, and H is our height. And I believe that's all the different variables we have. Okay, so we're going to use this to do a projectile motion problem. And here we go. I'll read to you. A small rocket is launched from a table. Really? Okay. It is 3.36 feet above the ground. And good to always highlight or underline stuff when you're doing these types of problems, any word problems. All right. The initial velocity, 64, launched at an angle of 30 degrees. And what do they want us to find? How far did it travel horizontally, and how long was it in the air? So, to the calculator we go. Okay, and we will clear this out. All right, so calculator is ready. Now, okay, before we go to the calculator, let's fill some stuff in here. All right, what is x? initial velocity was 64, and our angle was 30, and then t. Let's do the same for y, negative 16t squared plus, again, 64, this time sine 30, t, and what's our h? 3.36. So, go ahead and plug those into your calculator. T. Down here, negative 16t squared plus 64 sine 30 degrees t plus 3.36. All right. Now, take your time, make sure you type it in proper. Hopefully I didn't make any mistakes. All right, and if we press graph, we're not going to see necessarily everything we need to. So let's go back and check for any possible restrictions or changes that they suggest. Here, they're going to recommend we change our t from 0 to 3. Our x's are going to go from 0 to 150, and our y's from 0 to 30. So let's make that change in the calculator. Okay, you're going to go to your window, change it like we said from 0 to 3, 0 to 150, and 0 to 30. This will frame it up nice, so that we should see the whole trajectory of the rocket from start to finish. However, notice we were using degrees when we typed that into the equation, so go to your mode and change to degrees. And when you press graph, there is our rocket launch. Okay, now we need to figure out how far did it fly and how long was it in the air. So we're going to use trace. Now trace with me. And you'll stop when it hits the ground. Okay, and that's as close as I can get it to 0. And what do we have here? Okay, how long or how far did it fly? 116. All right, AP test is going to want you to use 3 decimal places. However, for me, I would certainly be happy with 1 decimal place. That's our rule. All right, how about T? How long was it in the air? 2.094 seconds. Pretty neat. Hope you learned something today, and hope you have a great rest of your day.